Hello students, welcome you all. In Pericyclic Reaction series, today I will explain Claisen rearrangement and Claisen cope rearrangement. In my previous lecture, I told you cope rearrangement and I discussed the various examples based on it. So this Claisen rearrangement, this is an example of 3-3 sigmatropic rearrangement which takes place under thermal condition. Now, so let us take the example of Claisen rearrangement. Now, suppose if we have aryl allyl ether, and suppose this is our allyl aryl ether. So this is allyl group, and this is your aryl group. So this can be called as allyl aryl ether. So this incidence of under thermal condition, 3-3 sigmatropic shift that will take place, and what we get orthoallyl phenol. So we get this orthoallyl phenol as a major product, and para-allyl phenol as a minor product. This would be the minor product. Okay, so here 3-3 sigmatropic shift that will take place. So for this, what I have told you for this sigmatropic reaction, first of all, we should give the numbering, and allylic carbon, that should be given number 1. So this is the allylic carbon 1, 2, 3. In the same way, here if you will see this, the allylic and this atom, this is allylic atom here, we can say this is oxygen atom, and this is now given number 1, this is number 2, and this is number 3. And in sigmatropic rearrangement reaction, 1-1, the bond, sigma bond between 1-1, that breaks. So now this bond will break between this carbon and this oxygen, this bond will break, this sigma bond will break. And being the most polar bond, this will break from here, and after that 3-3 sigmatropic shift that will takes place. Okay, so what we can write this product? So here you will have the double bond, carbon oxygen double bond. Now this 2-3 double bond, this aromatic double bond, this is converted into the single bond, and we have a bond which is formed between 3 and 3. 3 new sigma bond is formed, and we have this 2-3 double bond is converted into single bond, and one of the double bond you will have the new double bond between 1 and 2. This new double bond is formed. Now here if you will see, then the aromatic character of this, or you can see this benzene ring, this has become the non-aromatic over here. So now this is non-aromatic, unstable one, and in next step what will happen, the aromatic character that will be regained, and you have the, now this H plus which is removed from here, that would be taken by this O minus, and finally again you have this aromatic benzene ring over here, and this allyl group, you can see this allyl group is attached over here like this. So what you have seen, a 3-3 bond is formed over here. This is 3 and this is 3. So 3-3 bond is formed over here. Now, so this is an example of 3-3 sigmatropic shift. Now suppose if we have this example, and you have the substrate molecule like this, then what would be the product? So we may write here the product for this particular reaction. Now, so what would be the product in this case? So here again this 3-3 sigmatropic shift will take place under thermal condition. 3-3 sigmatropic shift, we can give the numbering 1, 2 and 3. And this is 1, this is 2 and this is 3. Now what you can see here, a new bond is formed between 3 and 3. New bond is formed between this one and this one. So the product that you may write, the product here, we should write the product. Here you will have this OH, and a new bond is formed between this one, this carbon and this carbon, and here you will get like this. So these are the two methyl group over here. So like this, the ortho product which is formed as a major product and minor product that may, as a para product that may also be formed. Okay. Now another example, if you will see, then suppose if you have already if this ortho position is blocked, then in that case this allyl group that will only migrate to this para position. This allyl group that will get migrated to this para position. If you want to write the mechanism, then again we should give the number 1, 2, 3, and this oxygen is again given number 1, this is 2, and either this is may be written as 3 or this may also be written as 3. Here two ortho positions are there, either you may write this or this as a 3. Now finally what I have told you, the new bond that forms between this 3 and 3, this new bond is formed over here. Now in this case, what I should write here now, so this bond under thermal condition, the cyclic shift of electron will start and you will have a cyclic transition state over here. A cyclic transition state is formed over here. So now a double bond, C double bond O, and we have this methyl group over here, and one of this 3-3 bond is formed over here. This is a new 3-3 bond which is formed. Now here in this example, what you have seen, the aromatic character is regained by the loss of this hydrogen atom, and whereas here the loss of hydrogen atom cannot take place. That's why what may be the product over here if you want to write. Then again if you will see here, then what should I give? A 3-3 sigmatropic shift will takes place again here. So suppose this is given number 1, this is 1, this is 2, and this is 3. 1, 2, 3 allylic chain, and this can also be given number 1, 2, and 3. This is another allylic chain. Now the bond forms between this carbon as well as this carbon, this one or this one, or otherwise I may write for my simplicity, I can write here in this way. I may write in this way, and now you may give numbering. This is number 1, 2, 3, and this can also be given number 1, 2, and 3. Okay. Now, so in next one, if you will see, then what I have told you, then 1, 1 dash, this sigma bond is breaks, and a new bond is formed between this one, this third carbon, and this third carbon, new bond that would be formed. So here if you will see this bond, double bond will come over here, this bond breaks and cyclic shift of electron start, and again if you will see, then a 6-membered transition state that would be formed. So how 6-membered? 1, 2, 3, 4, 5, 6. This 6-membered transition state would also be formed over here, and finally you may write now here we have the hydrogen, and this is now shifted to here. So this third carbon is joined with this third carbon. Okay, now in next step, the aromatic character that would be regained, by the loss of this hydrogen, and we have a para substituted phenol that we will get. If one of the methyl group is over here. Okay, so this would be the product in this case. Now, so suppose this is the case when the ortho position is blocked. If ortho position is blocked, then we are getting the para allyl phenol we are getting. So in Claisen rearrangement, the product that we get is the ortho allyl phenol as a major product, and if ortho position is blocked, then we may get the para allyl phenol, that may be the main product. Now suppose if both ortho and para position, is blocked, in that case what would be the product? So here suppose I have blocked this ortho position and this para position also. This ortho position and para position both are blocked. So in such case, under thermal condition, no reaction that will takes place. Because either this allyl group migrates to the ortho position or it migrates to the para position. So both the position are blocked. That's why no reaction will take place here. Okay. Now let us come to the Claisen rearrangement. Now, so this Claisen rearrangement, the simplest example of this Claisen rearrangement, if we have a now in Claisen rearrangement, what we took as a substrate molecule, that was allyl aryl ether. Now here the substrate molecule is allyl vinyl ether. So in place of aryl we have vinyl over here. So under thermal condition 3,3 sigmatropic shift will take place. How? Now we can give the numbering like before. So this is allylic carbon number 1, this is 2, this is 3. Now this allylic atom here, oxygen atom, is given again number 1, this is 2 and this is 3. And no doubt the most polar bond is this carbon oxygen bond, and I have told that this 1,1 bond breaks in a sigmatropic reaction. So this 1,1 bond will break, and what you will get, we get here, this bond breaks here. And finally the product that we are getting, C double bond O, this double bond is converted into single bond, new sigma bond is formed between 3 and 3, and this is the single bond and this is our double bond. So if this is alpha, this is beta, then this is gamma, then this is our delta. So what is formed as a product, if you will see, then gamma delta unsaturated aldehyde is formed. Gamma delta unsaturated aldehyde is formed. Okay. So now suppose if we have one of the group is present, over here, and suppose this is our R1, or this is R, this is R dash, suppose this is R dash. Now, so under thermal condition, so we have various reactions. We may have various reaction over here, and suppose here this R dash, if this is H, and that is the simple, we say it a Claisen rearrangement. All are actually Claisen rearrangement. So this is Claisen rearrangement, and the product formed, what we have seen, the product formed when R dash, that is equal to H, and R is suppose also H. Suppose R is also H. Then, or suppose I remove this one. Okay. So this is here the gamma delta unsaturated aldehyde is the product over here. In this case, when R dash or R is H, then it is called as the Claisen rearrangement, and the product here is gamma delta unsaturated aldehyde. Now suppose I write this R is OMe group, methoxy group, and this reaction that is called as the Johnson-Claisen rearrangement reaction. Okay, so here in this case, if this R is equal to this methoxy group, then this reaction is Johnson-Claisen rearrangement, and the product formed is gamma delta unsaturated ester is formed. Gamma delta unsaturated ester is formed in this case. Now suppose if R, this is NR2 or NMe2, if this is the group present over here, then this reaction is called as Claisen rearrangement, and the product formed that is what is the product formed over here? That would be gamma delta unsaturated amide that would be formed. This would be formed as a product. Now suppose if we have this as a OH, then that reaction is called as the Ireland-Claisen rearrangement. Simple. Okay. Now, so for different R, different name is given as per the discovery by the different scientists. Now, so suppose if we have what I have told you, suppose if this is a simple, this is allyl vinyl ether. So how we may get this allyl vinyl ether? So let us see the preparation of this allyl vinyl ether. So preparation of allyl vinyl ether, and finally the product, what I have told you, the product, this was the product which is formed. This is the product formed. Okay, so this was the product formed in this case. So gamma, alpha, beta, gamma and delta. Gamma delta unsaturated aldehyde is the product formed. Now how can we get this allyl vinyl ether? So this allyl vinyl ether that can be obtained, suppose if we have a acetal. Suppose if we have acetal, so this is acetal. So what is acetal? All of you know. This is the acetal. This is our acetal. Okay. Now suppose if we have only one OMe group and another OH group, then that is called as the hemiacetal. Here both methoxy group is attached over here, that's why it is called as the acetal. Or it may also be called as the ketal. Suppose if hydrogen is present, then that is called as the acetal. In place of hydrogen, if we have a CH3, then that would be called as the ketal. Now, so this is our acetal. So we have hydrogen, we have the CH3 and two OMe group, two methoxy group are present, then that is called as the acetal. And now, so how can we get this acetal? All of you, we have read already the reaction. Suppose if we have a carbonyl group, and this carbonyl group under acidic condition as a catalyst, and if we have methanol, then we will get here we will get the acetal. First of all, we will get hemiacetal and then we will get this acetal. Okay, so now I have taken this acetal and this under acidic condition. So one of this oxygen that will get protonated, and after protonation next step, this methanol being this good leaving group, it will leave out, and we have double bond over here, O and E. On oxygen we have positive charge, and this would be the product after this one. Now in next step, what you can see, if we have this allyl alcohol. Now this allyl alcohol, this allyl alcohol will act as a nucleophile, and it will attack over this electrophilic center, and now this pi bond will break and it will neutralize this positive charge, and finally what you can see, you may see a bond is formed between this carbon and oxygen. Okay, and here you have methoxy group. This carbon forms a bond with this oxygen, and oxygen is having the positive charge over here, and this is our allyl group. Now in next step, this proton transfer, the positive charge will get neutralized and proton transfer that will take place, and here we will have now positive charge will come over this oxygen. Now in next step, in other step, suppose, okay, if this is our acetic acid, as this reaction is taking place in presence of acid, and I will take acetic acid. Now this acetic acid, the H plus is utilized by here, and this acetate ion here acts as a base, conjugate base of this. So this acetate ion that can take one of the acidic hydrogen from here, and finally this methanol will leave out as a good leaving group. So what you have got? So we have got double bond over here, and so allyl, this is allyl vinyl ether. So like this we may get this allyl vinyl ether can be obtained from here. First of all, what we have taken here, we have taken acetal. Acetal is under acidic condition. So this is formed, and that is now treated with allyl alcohol, and finally we have got this allyl vinyl ether. Now suppose so from here what you will get, we get the product, that is this alpha beta unsaturated, sorry, gamma delta unsaturated aldehyde is formed from here if R is equal to H. Now second case, when this R is our methoxy group. Suppose this R is the methoxy group over here. This R is the methoxy group. Then what we will, how can we obtain this substrate? How we can obtain this substrate? This one. How we can obtain this substrate? Now we can obtain this substrate simply if we replace this hydrogen with this methoxy group, then naturally we will have one of the extra OMe group that would be present over here. Okay, so if we have, in place of hydrogen, if we have methoxy group, then we will have our substrate molecule for Johnson-Claisen rearrangement. Okay, so it means this is called, actually, if we have in place of acetal, it means in place of acetal we should have this OMe over here, and then that is called as the orthoester, and that is called as the orthoester. So if we are starting the reaction with orthoester, then we can get this substrate molecule, and from this substrate molecule we get gamma delta unsaturated ester will be the product. That would be the product in this case. Now suppose for this particular third case, that is Eschen-Moser-Claisen rearrangement, here if we put this R, if we put R is equal to NR2, if R is equal to NR2, then in that case the substrate that we will get is, this would be the substrate that we get for the Eschen-Moser-Claisen rearrangement, and final product that we will obtain. So in place of gamma delta unsaturated aldehyde, we will get gamma delta unsaturated amide we will get. So to get this one, so here for Johnson-Claisen rearrangement we are taking orthoester. For Eschen-Moser-Claisen rearrangement we should take the orthoamide. So in place of orthoester we should take the orthoamide. So here means we will take orthoamide, or we may take here NR2. So this is the orthoamide. Now the last case is the Ireland-Claisen rearrangement. In Ireland-Claisen rearrangement, in place of R we should have this OH. We should have this OH, and that can, and the substrate molecule, it means in Ireland-Claisen rearrangement, the substrate molecule that you will have, this should be the substrate molecule over here. So one of the, this, we say this lithium inulate is the substrate molecule. So, and we may get the lithium inulate also. So this lithium inulate is the substrate molecule for the Ireland-Claisen rearrangement, and this may be a acidic hydrolysis, undergo this acidic hydrolysis, and finally what you will get, and now it will undergo the 3,3 sigmatropic shift. 3,3 sigmatropic shift we will get, and this bond will break, and we are getting double bond over here. This is our OH. Okay, so here you will get the gamma delta unsaturated acid. So this will give you the gamma delta unsaturated acid that we will get. Okay.